So for today, I'm trying to get you through some more of that review packet, and we're going to be doing problems starting at number 39. Don't open that packet. Instead, I'm just going to remind you of things you'll need to know. If I just do the packet for you, that's not going to help you at all. You need to do those problems to practice those skills. All right, so one of the things you have to do is tell us what is the expected value of a warranty. Would you please draw two branches of a tree, because there's a probability that your item will work. Let's say you just bought a TV, and it's either going to work or it's going to break. And assuming it's already old enough that it's out of its regular warranty, you might be really happy you bought the extended warranty, because like TVs can be really expensive. It could be $2,000 TV, and all of a sudden it's only 9 months later and it's out of the warranty and it breaks. That would really suck. Well, you need to know the probability that it works or it breaks. And let's say that there's a 95% chance that it works, but there's a 5% chance it's going to break. I'm going to give you the rest of the info, and then you tell me what the expected value of the warranty is. All right, so this warranty costs, and remember, you should only figure that in at the very end. There's a value to this warranty. If I just gave it to you for free, it would be worth something. But you need to subtract off that it costs $100. You'll subtract that at the end to get the fair value. All right, and if it breaks, they're just going to give you all your money back. So we're going to say that a broken TV is actually just worthless. And so you would have lost $2,000 if your TV broke, but they're just going to give you all the money back. There are some warranties that are like that, money back guarantee. And your cost of this TV was $2,000. So effectively, they just gave you $2,000 for a broken TV that wouldn't be worth anything. So you get $2,000 if your TV breaks. Now, the question is, what is your expected value? Most of you know that on a warranty, you're going to lose money. That's why they sell them so hard, because they make money. You lose money. But that doesn't mean it's dumb to buy. A lot of people buy insurance, even though their expected value of the insurance is that they're going to lose a little bit of money, because the insurance company's going to make a little bit of money. But people buy insurance anyways, because if your car just gets destroyed one day, you can't afford usually to just, okay, I'll buy another $30,000 car, out of cash and my own money. Usually you buy insurance for that. So my point is, just because the EV is negative does not mean it's stupid. Most insurance is got an EV that's negative. All right, by now you should have been multiplying some probabilities and amounts and adding them all up and then figuring out what the actual expected value is at the end here. I'll pause for a minute while you finish this off. All right, let's see how you did. There's a probability and amount. What's the amount you get if your TV works? Zero. So there's a 95% chance you're going to get nothing from the warranty, because 90.95 times 0 is 0. Then there's also a 5% chance that you're going to get $2,000 you wouldn't have got, because they'll give you that money back. And your TV is worthless now because it's broken. And all right, so you got $2,000, but there's only a 5% chance of that. All right, what is that worth? $100. But then you take away the cost of $100, your EV is 0. Raise your hand if you had 0. Awesome. Now, does that mean you should buy it or not? Now it's a judgment call for you. Do you think it's worth having that peace of mind? Because on average, people will not make any money buying that warranty. Now, I can tell you, I personally bought warranties on items that are very portable, because those break more. Like, for instance, your TV sits at home on a shelf. It's not likely that it's going to fall off the shelf, okay? But when you take something with you all the time, like a laptop, and you're always bringing it around, and like your iPads, you're bringing them around all over the place, then I think the probability of them breaking goes up a lot, okay? But for things that sit still at home, I don't feel as big about it. But I think warranties are smart when you're hauling it around all over the place, because I think your probability of breakage goes up. Okay. Expected value is one kind of question. There's a table like this, and I'm not going to ask the same question, but would you just look at this table here? Don't open it on your iPad. Just look on the board. And would you please tell me, given I'm only going to talk to people who walk, what's the probability they're a senior? Given walk, probability senior. Now, if I had just said senior, you should have used 441. I did not just say senior. I said, given that they walk, that means I can only pick from these numbers. If you use any other number, you're doing it wrong, because I said given that. So then, it's out of, I think it's smart to start with the thing on the bottom, which is what it's out of. It's out of 259, and then the seniors are 84. Raise your hand if you had that. Awesome. Any questions about that? That is called a probability, but not just a regular probability. This is a contingent probability, because contingent that I only talk to walkers. All right, good enough on that. Do you remember this kind of question? All right, so I'm going to give you one that's like that with a circle inside of a square. This is called a circumscribed circle. It perfectly touches all the edges of its square that goes around it. And I want to know the probability you'd hit this little area around the edges of it. And you only need to know one thing, the radius of the circle, because that in turn would tell you how long the square's sides are, right? So I'm going to say that that's 3. Would you please set up and find the probability you'd hit the shaded region? Always to use a framework, what you want goes on top, and everything that's possible goes on the bottom. And use 3.14 for pi, so we can actually get decimal answers for this. Now, clearly you know that the area of the circle is important. If you're not sure even how to use it, just find the area of the circle. So I'll say the question one more time. Let's say that you're dropping a penny onto this board, okay? And you know it's going to stay inside the square. Maybe there's like walls up around the edge of it or something. So that's for sure going to land inside the square. But the probability that it hits the shaded region and lands there. All right, so is what you want the circle? No. What you want is the stuff that's not the circle, that's in the square, but minus the circle. The thing that was possible is the square. And the square's sides are 9 by 9, and therefore what's on the bottom is 81. Raise your hand if you had an 81 on the bottom. Cool. Do you get how I got that? Oh, I just did that wrong. I'm so sorry. It's not 9 and 9. You probably were just followed me right into the trap. It's 6 and 6, so it's 36. Sorry about that. 36 on the bottom. Okay, now, what's the thing on the top? The thing on the top is not the circle. If it was the circle, then it would be pi r squared, which would be pi times 3 squared, which would be 9 pi. And I said to use 3.14 for pi. So let me get the actual decimal for that. What is 9 times 3.14? And it's 28.26. If I wanted to hit the circle, I'd just put that right here. But I don't want to hit the circle. So I have to say the square minus the circle. 36 minus 28.26. Let me get my final answer then. What is 36 minus 28.26? What is that divided by 36? 0.215. Raise your hand if you had 0.215. Nice. Okay, good. So, question? Okay. Now, let's talk about CC over C. Do you guys remember these? There was a whole lot of times we did this. I'll give you an example that doesn't involve cards because not everybody's awesome at cards. If we do ones about cards, you can ask and we would have a chart that shows you all of the things that are in a deck of cards. But we'll do something you can all relate to. There's people in here who have black shoes or dark colored shoes, and there's people in here who have whiter colored shoes. And sometimes they're more gray because they got dirty or whatever. But bottom line, let's say that I have 10 people, actually self-identify on this one, who has predominantly black footwear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is going to be the black footwear. There's 10 of them. And then I'm going to assume that the rest of you would identify as having generally white shoes. So I may be wrong on that, but I'm going to go with it anyways. I'm going to say that there's 20 of you with generally white shoes. Now, that's the basics. From that, you cannot answer the question. I now need to tell you the rest of the story. I'm going to grab 2 of you at random. What's the probability I get one who has black shoes and one who has white? Take a second, just set it up. Don't even type it all in, it takes too long. If you set it up right, I know you'll get it right. Question is, can you set it up right? You'll want one of each. All right, it's as simple as this. You got 10 people with black shoes, 1. 20 with white, 1. Then the totals go down here, 30 and 2. Raise your hand if you set that up right. Cool. All right, so if we wanted to do this without the probability part, what would I do? What if it wasn't probability? What if it was just, how many ways can this happen? It's really simple, guys. You don't need this then. Then it's how many different ways could that happen? And you do 10C1, 20C1. Okay. What if the order mattered? Then what would we use? A P. Good. I want to give you that kind of question. There's actually 36 of you in this room right this second. We're going to use that number here. If there's 36 of you, and we all run across the parking lot, and we keep track of first, second, and third place, how many different ways could people finish? It might be this person, Bob, Jim, Susan, or it could be Susan, Bob, Jim, and they're all different because the order matters. We keep track of first, second, and, did I say just 2 places or 3? 3 places, okay. Actually put this one in the calculator. It's a big number. 36. Is it a P or a C? P. 3. All right. Summerfeld, what'd you get? It's a lot of digits.
42,840.
Raise your hand if you had the same thing. Nice. Okay, good. Now, I seriously think there's only one thing that you weren't taught in this class that was taught in the higher algebra regular class. And I'm going to teach you that right now because I don't want them to be able to be like, you guys didn't even learn that. So I'm going to tell you something because it involves factorials because you got to know what those are anyways. All right? The word zoo. How many different ways could you rearrange those letters? Well, the weird twist is there's 2 O's. So you might think it's just 3 factorial because you got 3 choices for the first letter and 2 choices for the next letter, but it's more complicated because the O's are the same thing. So the answer is not 3 factorial. If the letter had been cat, how many different ways can you rearrange that? Then that would have been 3 factorial. Done. But zoo, it's more complicated. Does anybody want to try? You can figure this out. It's not super complicated. You want to tell me what you think we would do for the letter zoo? Z-O-O? Dozier. There is another factorial involved. Can you tell me exactly what to do? 3 factorial? Yes?
Minus 2 factorial.
Oh, you're warm. There it is. Because why? Because there's 2 O's. And O's are different than the other letters in that if you have an O here and an O there, they're the same letter. And so you don't have as many choices for that spot. All right. I'll give you one more like that. The word Mississippi. How many different ways can that be rearranged? M-I-S-S-I-S-S-I-P-P-I. Count it up. Is it just 11 factorial? No, not quite. Over. Four factorial. Is that the answer? No. It's part of the answer. Who wants to finish it? Dozier, what do you think?
2 times 2 factorial times 4 factorial.
Okay, I got the 2 factorial because there's 2 P's. I got the 4 factorial because there was 4 S's. What else? So I should end with what?
4 factorial.
Yep. All right, now there's nothing, as far as I know, that you haven't learned that regular learned. They learned that. You didn't learn that. Okay. So, how about, let's see if what else is on your review packet. Ah, yes, remember these? All right. They can be harder than you would think. I'll give you an easy one and I'll give you a harder one. What's the probability that I grab a random kid and they like Leanne Chin? And if you say 0.1, you're wrong. Because these people like Leanne Chin. You got to keep it to the question at hand. They didn't say anything about Chipotle. They didn't say anything about McDonald's. They just asked, do you like Leanne Chin? If you ask all these different groups, these would all say yes. Raise your hand if you knew that. Okay, good. Then, here's a more complicated question. Given you're only talking to the Leanne Chin likers, what's the probability they like Chipotle? Don't say it. Use your calculator. It's a decimal. I'm going to say it one more time. Given I'm only going to ask Leanne Chin kids who like Leanne Chin, what's the probability that they will say they also like Chipotle? All right. I always told you that the hardest problems you'd have to come back to what you want over what's possible. And what's possible is all those things added up. 0.36 is what's possible because it's only these. And I think I added that, right? Did you guys get that too? So they add up to 0.36? I think so. All right. Then what I want is kids that like Chipotle, which is these two. And together, that makes 0.13. Who had that? Okay. Do you have any questions? I could have done it wrong, but I'm pretty sure I did it right.
What is 0.05?
Yep, 0.05 and 0.08. I'm pretty sure make 0.13. Think of it as 5 cents and 8 cents. It's okay. Every now and then, people's brains just don't add up. Okay, so here's the hardest question of all, and I predict less than half of you will get it right. Because as soon as I say not, it makes it so much harder. All right. Given I only ask people who do not like McDonald's, what's the probability they like Chipotle? Given not McDonald's, probability Chipotle. Want? Pass. All right. What a lot of people are going to mess up is the possible, and that is the only things that are possible if you don't like McDonald's are those four numbers. A lot of people forget the 2. 0.32. Double checking that. 10, 20, 30. Yep. And then what I want was people that liked what? Chipotle. Do these people like Chipotle? Do these people like Chipotle? Yep. So put them together. 0.20. All right. And now, let's move on to the second to last page. Actually, this is perfect. We're on to the last page, which means if I cover all this stuff, mean, median, mode, standard deviation, and all that stuff, then we'll just have a little bit of review of that stats stuff tomorrow, but I'll do most of it today. So that way, if those of you that are eager beavers can just finish your packet tonight. All right, so this is a CC over C. If I tell you that, it'll help, but it's still a hard question. They're going to get new iPads. I think it's next year. So at least some school, for sure, they'll have new iPads next year. So imagine that they just got a huge shipment of iPads. And for our high school here, it'd probably be like 3,500 iPads. They typically find out of a group like that there's 2 defective ones. The question would be, if you grab 5 and you just looked at 5 of these, 3,500, what's the probability you'd get one that was defective? I'll say that again. 3,500 iPads get shipped to Minnetonka High School. Typically, there's 2 of them in the stack that are defective. Okay. The principal walks down. He grabs 5 off the top. And he just checks them, and then whoa, he got 1 that was defective. What was the probability of that? All right, if I hadn't led with this, it probably would have been a really hard problem. But I did tell you it was a CC over C. Why? Because there's some of these, which are defective ones, and some of these that are working ones. And there would be 3,498 working ones and 2 defective ones. And we want to get 1 defective one and 4 that work, totaling up to 3,500 and choosing 2. Raise your hand if you set that one up right. That's not that many. That's a hard problem. Any questions? All right. So now let's get into hardcore stats. You ready? Imagine I give you a normal distribution. And this is about shoe size, and in this class, it turns out that there's an 11 right there. I want you to write down everything that you would know about that. What does that mean? If this is a normal distribution, there's 11 right there. And if all you do is write down, oh, the blank is this, well, then you missed something. So some of you are going, oh, I can't remember. Is that the mean or is that the median? And you're both wrong. Weird. Because it's the mean and the median and the mode all rolled into one. That number 11 means that if there's truly a normal distribution, that the average is 11, which is the mean, The median is 11, which is the middle size would be 11, and the mode, the most common one, would be 11. All right. Next, if I asked you this, how many people, no, what percent of the people would have bigger than 11? What would you say? 11 or bigger. Now this gets weird. I know this is going to seem wrong to you, for some of you, because you're like, but those 11s, that's the most common number. If you include that number, then how do you factor that in? Don't overthink it. From here over is 50% of the data. All right. Now, did I tell you that you may want to memorize the one standard deviation out numbers? Yeah, because you'd just be smart for you to know. The total of that is not 30-something, but what are you telling me? You're telling me something that's correct. 30-something percent goes where? Yes, 1/2 of this is 34%. That means together, one standard deviation in both directions means what percent? 68. And I said 67. I was rounding wrong before. It's 67 point something, but it rounds to 68%. All right. So 68% would be between, well, if I needed to get these two numbers, what haven't I told you? Is that a phone? What haven't I told you? Standard deviation. Good. Remember this weird little symbol? Let's say it was 2. What could you say about 68% of the people? Between 9 and 13. Okay, good. All right. Now, how about the box plot? Is that different? Oh, yes. This time, the mean, median, and mode are not all in the middle. What's the middle one on a box plot? Okay, so let's imagine this is shoe size again. And let's say that the smallest in here is a 5, and the largest shoe in here is a 14. Then let's say that this Q1 thing comes out to 8. There's a 10 here, and then there's a 13 here. I don't want you to think that the whiskers have to be the same size. That could be a 1, and meanwhile that's a 3. The difference between the 5 and the 8, you know? Do you know the name for all 5 of those numbers? Because that's called the 5-number summary. Say them, Brandon. What's this?
5 is the min.
What's this?
The Q1.
What's that?
Median.
Yep.
Q3.
Q3 and max. Very good. All right. Now, here's the 2 questions that aren't on the chart, but you need to know. What's the range and what's the IQR? Range and IQR. In a moment, I'm going to ask you to compare those 2 answers with the kid next to you. What's the range? What's the IQR? If you forgot it, it's okay. We'll remember it together.
Have you watched Shameless?
All right. For the range, it's very common for kids to say 5 to 14. Nope. You got to actually subtract them. 9. IQR? 5. Who had 9 and 5? Okay, good. Working 9 to 5. What a way to make a living. L1, L2. You put some numbers in a list, and all of a sudden, you can make a something something. Do you remember the thing we figured out from this? A what? A stem and leaf plot is one of the things you can do with this. Okay, let's do one of those. 2, 3, 4, 1, 1, 7, 2, 8, and 0, 1, 4. How many people were at the party? 8 people at the party. This is ages of people, by the way. What was the oldest person?
47.
47. What was the youngest one?
20.
20. Could you find the average if you needed to? Yep. And you'd add up 20 and 21 and 24, 32, 38, 41, 41, and 47. Okay, good. Could you find the middle one? There's 8 numbers. So what would you do if there's 8 numbers and that means there's 2 numbers in the middle? You take the 2 middle numbers and you
Add them and then divide by 2.
average them, yes. Okay, good. Then, what's the range?
27.
47 minus 20. 27, good. All right. Now, if you had to find the Q1 and the Q3, do you know where you'd go? Like, what would you do on the calculator if you had to find Q1 and Q3? You'd make a list and put it where? On the calculator under stat. Let's do that. Take these numbers, put them into stat, edit. There's 8 numbers there. Put it in stat, edit. Don't put it on 2 lists. Don't do that. This is just a list of 8 numbers. 20, 21, 24. Okay, so don't put this into 2 lists. Just put a list of all the numbers. 20, 21, 24, etc. And then I'd like to know the standard deviation. If you know where to find that, I hope you do. Now, just realize there is maybe one more thing that they learned in regular higher algebra that you didn't learn, and I got to ask you this question. Either you know it or not. Did I teach you the R value? No. All right, then I'll show you that too, because I think that's another thing they learned that you didn't in stats. So for right now, just go find standard deviation, then I'll show you how to get the R value. All right. One more thing I didn't ask about this, but we could do. Was there a mode?
41.
41, because it happened the most. Good. Now, if you've got these numbers entered on your list, 1, then this little dude is called the what? Standard deviation. And what was it in this case? Mr. Buick, you got this one?
No.
Okay. Do you have the numbers entered on the list yet?
Yeah.
Okay. Go to stat, calculate 1 var stats. Stat, then
How do I erase like numbers from a previous edit?
Oh, I'll help you do that in a minute. I'll tell you just verbally here, but then I'll go to somebody else. Hit the DEL key on the numbers you want to get rid of. The DEL deletes them. Sommerfeld, can you tell me the standard deviation here? If you assume you've got 1 var stats done.
9.64.
Anybody verify 9.64? Okay, good. Now, if asked, I could ask you to put in another list, and then we'll see if there's a correlation between the two. All right. So remember how this was ages? That's going to be our list 1. List 2 is going to be, let's see, what's something that would definitely go up over time? Number of gray hairs. Okay, it's true. Probably these people that are 20 or 21 or 24 don't have any gray hairs, but yeah, when you get older, some of you are going to get gray hairs. 0, 0, 0. The person that was 32 has 4 gray hairs. 12, 20, 18, and 25. Now, does it look to you like there's a correlation? I was trying to make it so there was a correlation. How strong the correlation would be, I'll teach you how to do that in a minute. For right now, would you just enter these two, L1 and L2? Yes.
You have to learn how to graph these.
Nope, you're not gonna need graph, other than on paper, you should be able to graph these. You just have it, X and a Y and put a dot.
Oh, okay.
Like 20 would go with 0, so for example, if I had 20 down here, they would have gray hairs of 0.
How would you do the slope? Would you just do best fit line?
Yes, so I'm so sorry that I am confused between the two, but I literally taught this all day differently in all my classes. So I don't know, I think we taught you linear regression. Did we teach you linear regression? Where you put these two into well, how about this? Did we do 2 var stats?
No.
Okay, then, once you've got these all entered on list 1 and list 2, then I'm gonna show you the stuff you didn't learn. It'll be brief. Because I don't want you to feel like you missed out on something that they learn in regular. All right, once you've got L1 and L2 both entered on list 1 and list 2, would you please raise your hand so I can know that you've got them? All right, good, then we will proceed. Now, so far, all you've had to do is 1 variable stats, 1 var stats. Well, do you get that there's 2 variables now? Okay, so then we could do something called 2 var stats, but we're not going to. I know you can go play with that later if you want to. What we're going to do is what's called a linear regression. But before we do, I want you to go to the button called Catalog in the lower right-hand corner of your calculator. Lower left-hand corner. Above the 0 key is the Catalog button. Go to the Catalog. And then arrow down a whole bunch of times until you get to Diagnostic On. Diagnostic On. Once you get there, hit enter a couple times so you make sure you turned it on. The calculator will say, diagnostics are on. Okay, once you get diagnostics on, you can do something really cool when you have 2 sets of numbers like this. You can tell how correlated they are. And it's called an R value. All right, so did you get your diagnostics on? It was under catalog. Arrow down till D and then find diagnostic on. All right, now that you got your diagnostics on, go to Stat, Calculate, LinReg, which is linear regression.
The X plus B or A plus B.
The top one, the first one that says LinReg. And then hit enter, enter, enter until it tells you the linear regression equation. Should after you do it, it should say y equals ax plus b, and then it tells you what a is, and then it tells you what b is, and then the crucial thing is it tells you what r is. So, can you read me, Libby, the a value?
It's 0.954.
954? Thank you. And the b value?
Negative 21.6.
Can you guys verify those numbers were the same for you? Good. Just to make sure you didn't type one number wrong or something. And then the r value.
The R is 0.964.
Okay. Cool. Now, let me tell you what this means. They just gave you an equation for this. They told you that an equation would be y equals, and I'm going to round, 0.95x plus the b value, which is a negative, so it's not really plus, it's minus 21.6. And the cool part is, that's the equation for this, so from now on, if you tell me an x value, I can tell you what the y would have to be. You can stick in the number right there, and it's the line of best fit. It doesn't necessarily fit perfectly, and this is what tells you how perfect it was. If it had been a perfectly straight line, then this would have been a 1.0. Do you get that this was pretty close to 1, and therefore there's a strong correlation between age and gray hair? All right, now that's the thing you didn't learn about stats. Now you did. Now, can we test you on that? No. I just thought you might want to know that, because I didn't want you to feel like you got left behind in any area compared to regular. All right, so at this point, I'm going to end our discussion of stats, and I might bring up one more thing tomorrow. You remember Z-score? You learned Z-score, they didn't. Okay, but you gotta know that for your test. So I'll remind you what a Z-score is and a couple other stats things. But then tomorrow will be pretty light, and you'll have a bunch of time to work and ask questions. And I might throw out like a 5-question final, meaning just if this was the final was tomorrow, which it isn't, would you have gotten these 5 questions? All right, so we'll do like a little practice final. It's not the real final is way bigger than 5 questions, but anyway. That's the plan for tomorrow, and that's all I got for you for today. Finish your review packet.